I'm Principal Sheep. Welcome back to our classroom. Today, I'll be teaching you about how to prove something in math. Proof is like a logical argument. It shows why something is always true. Remember, when you're proving something, you need to show the path that you have taken, concisely and simply. Trace down the steps of your thoughts in an orderly manner and write them down. Or an easier option is writing them down as you think them. You need to write down the process that led you to the formula, which is the thing that you need to prove. I'll give you a few tips to tackle proof. You need to start with what you know, the given information that is in the expression, sentences, or equation. Use algebra to write down each step clearly. For example, an even number is 2n, 2n plus 2, and then 2n plus 4, and so on. An odd number is 2n plus 1, 2n plus 3, and 2n plus 5, and so on. Consecutive numbers are n plus 1, n plus 2, and so on. You need to look for patterns or relationships between the numbers or algebraic numbers that the equation has given you. Some problems can be proven by substituting integers. The statement if x is greater than y, then x over y is greater than 1 is not always true for all integer values of x and y. The explanation is both x and y are positive integers. In this case, the statement is true because, for example, if x equaled 4 and y equaled 2, then 4 is greater than 2, and 4 over 2 is 2, which is greater than 1, which is obviously true. But in case 2, both x and y are negative integers. In this case, the statement is not always true. For example, if x equaled minus 2 and y equaled minus 4, then minus 2 is obviously greater than minus 4, but minus 2 over minus 4 is a half, which isn't greater than 1. In case 3, x is positive and y is negative. In this case, the statement is not always true. For example, if x equaled 2 and y equaled minus 1, then 2 is bigger than minus 1, but 2 over minus 1 is minus 2, which isn't greater than 1. But in case 4, the values of x and y are between 0 and 1. When x equals 0.5 and y equals minus 0.5, then 0.5 is bigger than minus 0.5. But 0.5 over minus 0.5 is minus 1, which is less than 1. Therefore, the statement is only true when both x and y are positive integers. I'll give you 2 questions so that you can practice proving something. Prove that the sum of 3 consecutive numbers is always a multiple of 3. Number 2, prove that brackets 2n plus 1 squared minus brackets 2n minus 1 squared is a multiple of 8 for all positive integer values of n. For example, let the consecutive numbers be n plus 1, and n plus 2. Their sum is n plus 1 plus n plus 2, which is 3n plus 3, which is 3 brackets n plus 1. Since 3 brackets n plus 1 is a multiple of 3, the sum of 3 consecutive numbers is always a multiple of 3. The answer to practice question 2 is brackets 2n plus 1 squared minus brackets 2n minus 1 squared equals brackets 4n squared plus 4n plus 1, brackets 4n squared minus 4n plus 1, which is 4n squared plus 4n plus 1 minus 4n squared plus 4n minus 1. So the 4n squared cancels itself out. The minus 1 and plus 1 cancels itself out. So we are left 4n and 4n, which added together is 8n. And since 8n is a multiple of 8, this equation must be a multiple of 8 for all positive values of n. This equation can also be easily solved using the formula a squared minus b squared equals bracket a plus b brackets a minus b. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.